Hey everybody. Today we're working on contingency tables in R. A contingency table is a way of summarizing the relationship between a couple of categorical variables in a dataset. In this vid, I'm going to be looking at the car seats dataset that's included in the ISLR2 package, which is a package of datasets supporting the excellent book Introduction to Statistical Learning with Applications in R, which I highly recommend. So the variables I'm going to be interested in today are urban, whether or not the location of the place selling these car seats is considered urban or not. That's yes or no. And shelf loc, so shelving location. Is it a good, bad, or medium shelving location? So you should be envisioning a 2x3 table with the 2 categories for urban and the 3 categories for shelf location. And each of the 6 cells in that table should be a count. How many urban locations had bad shelving locations, and so on. So the main command that I'm going to be using in R is the table command, which, as it says here in the help file, will get you cross-tabulation from data sets. And the fundamental syntax that we're going to use is just table, and then the name of the data set. In this case, it's car seats. I say the name of the data set, it's really the 2 variables. So the first one that I'm going to want is urban. We're putting in the row names for the table first. R in general does rows, then columns. And then I'm going to do the variable that's corresponding to the columns in the in the contingency table that I'm going to create. So car seats, dollar, shelf location. And let's just print that out and see what we get. As we were hoping, we have a 2x3 contingency table. So in this set, there are 22 stores that are selling car seats in bad shelving locations, and the locations are not considered urban. No, let's save this table as I don't know, let's just call it T, and learn a little bit more about what a table object is in R. So we can do a structure command on this and see the table is actually a type on its own. In particular, notice that we have a dimensions attribute. We could potentially have some dimensions names. We could have some dim names. Let's just see the dims here. So dim of t should give me 2, 3, number of rows and number of columns. I should say right at the outset that although this kind of looks like a data frame, this is a very different object than the sorts of data frames we normally work with, and there's a very specific reason that I'm not saving this as any sort of data frame. This isn't tidy. Here we are not in a situation where rows are observations and columns are variables. Instead, this is essentially a matrix comparing 2 categorical variables. So the most natural thing that you would want to do once you have a contingency table is to compute some marginal counts. In other words, how many stores in this sample were considered urban, how many were considered non-urban, how many stores used bad shelving locations, good and medium shelf locations. So there's any number of ways we can do that in R. The first thing I want to do is going to be add margins. This is a nice little command. By the way, these are all from the base R package. I think maybe 1 or 2 of them come from the stats package. So the syntax, the capitalization, and so on is a little less consistent than we might like. That's just something you have to cope with when you deal with these older functions. So the add margins command has done exactly what it says on the tin. It's added an extra row and an extra column, and you can see we've got the row totals and the column totals. So 22 plus 28 plus 68 is 118. In particular, we can see that we have a grand total of 400 observations here. That corresponds to the number of rows in the car seats data set. If I were to get the dimensions on this, you can see now I have 3 rows and 4 columns. Maybe let me just keep that command separate so that I have everything in the notes. Let's see here. There are other ways, of course, to get these marginal totals. I'll point out just one more. One that I've used occasionally is margin sum. and you feed it the name of the table, and it will tell you that the grand total is 400. If you just want row totals, you have to tell it you just want the sums over dimension 1. So the row totals are 118 and 282. So it here is using the original table that only has 2 rows, not the expanded table that had 3, including the sums. And of course, we can get the other marginals as well, just like that. One other command that I think is fun to know here is proportions, which is actually, I think, the same as prop table. I just got in the habit of using proportions, so I'm going to stick with that. And again, you can just feed it the name of the table, and now it's going to give you the proportions in each of those, the proportions of the total that are in each of those cells. So 7% of the stores in this sample were considered non-urban and had good shelving locations for their for the car seats. The syntax here is going to be a lot like those margin sums, and so we can also do things organized by row. So what we're seeing here now is that just under 24% of the car seats, of the stores that were not considered urban had good shelving locations for the car seats. So basically the row totals here should add up to 1. And of course we can do that for column totals as well. And now you can see the columns add up to 1. So among stores that had bad shelving locations, about 23% were not considered urban, and about 77% were considered urban. The very last thing I want to do here is just quickly make a contingency table by hand. So this is essentially a matrix, and so what I'm going to do is just to put in all the data that I want in my table and then specify the attributes, specify how I want that data to be organized. So I don't know, let's just make a vector called counts, and I'm not going to do anything with this particularly, so let me just put something kind of random. I know I could do that with a colon. Thought of that after the fact. Okay, so this is just the vector 1, 2, 3, 4. And let's make a matrix out of that. And all I have to do really is specify the data that's going in and then how I want it organized. So in this case, let's do 2 rows so that we get a 2 by 2 matrix, and we can print that out. I have a whole video on making matrices in R. I'll throw a link to that up top. Notice when I did this matrix, it filled in things by column. So 1, 2, 3, 4, filling the top from the top left down, and then moving over to the next column, and so on. If you want to fill it the other way, you can do by row, and you'll see you get a slightly different result there. No big deal. So once you've got that, you can do all your usual stuff here. For instance, we can do add margins on this to M, and that'll just expand it just a little bit.